9.2. See, I didn't start with an okay. We are doing example 1, page 447. So in these, we're talking about points of discontinuity. Okay? And so in calculus, when we do these, there's different points where graphs kind of jump over a section. So we've talked about when you have asymptotes and your graph comes up to it and then there's a dotted line and it jumps over. These are points in a line that would cause there to be non-permissible values, so they just jump over the little point. Okay, so when we look at this equation, it says sketch the graph of the function, and it's x squared minus 5x plus 6 over x minus 3, and analyze its behavior near its non-permissible value. Okay, so when we look at this, we'd think, oh, there's a vertical asymptote at 3, because that's what would make the bottom 0. But first we should probably factor the top, and once we factor the top, we will notice something, and we'll notice that there's going to be a point of discontinuity instead of an asymptote. So how do we factor the top? We need something that multiplies to 6 but adds to minus 5. Minus 3 and minus 2, so we'll write them as x minus 3 and x minus 2, and our bottom is x minus 3. Okay, so what should we be doing at this point when we see those two x minus 3's? Yeah, vigorously cross them off, aggressively. Okay, so when we cross those off, you no longer have a vertical asymptote in the bottom because we crossed it off. But what you do have is a point of discontinuity. So the point that we crossed off was at 3, right? Because when x is 3, this is going to give us a point of discontinuity. And what we do is we take this value and we plug it into whatever we're left with. So the only thing we're really left with is x minus 2. So if we took 3 and we put it into this equation, we'd have 3 minus 2 is 1. So we'll have a point of discontinuity at 3, 1. Okay, and I'll show you what that looks like. So if we have x minus 2 left, if we were going to graph that, what kind of shape would it be? Not shape, but is it going to be like a parabola? Is it going to be, what's x minus 2? Straight line. Okay, so we remember how to graph straight lines because if there's nothing in front, we can assume that's a 1 over 1, which is going to be our rise and our run. Okay, so our rise is going to be here, our run is going to be here, and this is where we start. It's our y-intercept. Okay, so if we were graphing this, we would go down to minus 2 and put a dot, and then we would rise 1 and run 1. So rise 1, run 1, gives us a point right there. Okay, and we would draw our line. Okay, but before I'll draw my line here, but before you draw your line, we need to remember this point of discontinuity. So at 3 and 1, that means our line isn't continuous. Continuous means I should be able to hold my pencil and just follow along. So we're going to have a jump somewhere where we have to pick our pencil up and move it. And the point where we pick our pencil up and move it is going to be 3 and 1. So 1, 2, 3 over and 1 up is going to be like that. So essentially you're going to have a line. Oh boy, here we go. You're going to have a line, and at 3 and 1, you're going to have a spot where it's empty. That's called a point of discontinuity. Moving to example 2. Example 2 is on page 448. It says compare the behaviors of the functions. So we have two functions here, this one and this one. And they want us to compare the behaviors near any non-permissible values. Okay, so the first thing when I see these, I think I should factor and I should break it down so that I can see what it looks like. So how would I factor the top of this f of x one? Yeah, I could take out an x, and then I would just have an x minus 2 in the top. And what about in the bottom? If I took out a 2, then I have a 2 minus x in the bottom. Okay, because I just divided the... So if you remember, we can't just cross off an x minus 2 and a 2 minus x. We can cross them off, but what do we have to put there? Yeah, we have to make a negative, okay? So if I cross these off, I will put a negative somewhere in the equation to show that I crossed off opposites, okay? And let me just factor, before we finish that one, we'll factor this g of x one. Okay, so what can we do in the top of that one? We can take an x out. And then in the bottom, we can factor it the same as the other one, taking a 2 out. But is there anything to cross off in this situation? No. Okay, so in f of x, this, when we cross something off, that creates a point of discontinuity. Okay, so in this one, we're going to have a point of discontinuity at what? 2, because that would make the bottom 0. And then if we take this value of 2 and plug it back into what we're left with, and hold on, what we're left with is only an x over a minus 2. So if we took the 2 and put it in here, we would have 2 over minus 2, which is just minus 1. So our point of discontinuity is going to be 2 comma minus 1. Okay, and what does this one have for a non-permissible value, like this g of x question? Yeah, it has a vertical asymptote at 2. Okay, because if I had a 2 in here, 2 minus 2 would make the bottom 0. So this one has a vertical asymptote at x equals 2. So really you're saying x cannot equal 2 in this one. And in this one you're saying it has a jump or a point of discontinuity at 2 comma minus 1. That's the difference between the two equations. Okay, so example 3 is a matching question. So we're just taking these equations and we have to match them from the graph. So we can do this any way we want. You could even get out a graphing calculator and check what they would look like on a graphing calculator. One way that I like looking at them is by factoring and seeing what's going to happen. Okay, so if I factored this one, I could take an x out of the top and I would just be left with x plus 2 in brackets. And my bottom, how do I factor that? That is difference of squares. So x minus 2, x plus 2. Okay, so I could cross the x plus 2's off, and that gives me a point of discontinuity, right? So I would have a point at where? Minus 2. And then if we took minus 2 and plugged it in, what I'm left with is I have x over x minus 2, right? So if I plug in a minus 2 there, I'd have minus 2 divided by minus 4, which is half. Or minus, no, half, yeah. So 0.5. So which graph has a point of discontinuity? Yeah, this guy does. So he would match with the first equation. Okay, and if you notice, the point is at minus 2 and 0.5. You take the minus 2 and you put it into the equation, back into what you're left. So minus 2 over, and this is minus 2 minus 2. So a minus 2 over minus 4 is a half. Okay. So now if we look at the next one, so these guys match together. This one, still we can factor with an x minus 2 and an x plus 2, right? And can we cross anything off, really? If that's our top, is there anything to cross off? No, so what are those x minus 2's and x plus 2's then? Yeah, asymptotes. So they can't cross there, so they're going to be dotted lines. So which one goes with that one then? Yeah. This one has asymptotes at minus 2 and 2, so he matches with that one. And that must mean that guy matches with that one.